This is the second half or part 2 of our motion problems. So we have a problem here with a steamboat. So we're going to go ahead and set up our distance, rate, time. Way that we can organize. So we've got distance, got rate, got time, we've got a steamboat, and it's traveling with the current. And then we've also got a time where it's going against the current. So we can look at upstream and we can look at downstream. And it says that a steamboat can travel at an average speed of 11 miles an hour. So we know the rate of the steamboat up and downstream, it's 11. Difference is that if we're going upstream, we have a current against us, and downstream, we have a current with us. So it's asking to find the speed of the current. So I don't know the speed of the current, but if I'm going upstream, I could subtract the current from my 11 miles an hour rate, and that would give me the overall rate. I also know that it takes the same amount of time to go upriver and downriver. Now I need to look how much distance is covered upriver. So traveling with the current, the steamboat can travel 77 miles an hour. So that's going downstream with the current. And in the same amount of time it takes to travel 44 miles against the current. So what we have is a distance equals rate times time, and distance being 44 divided by 11 minus c is equal to the time upstream. And then downstream would be 77 divided by 11 plus c. So we can do cross products here. It is a proportion, or we can multiply the entire equation by the LCM, and the LCM would be 11 plus c times 11 minus c. So either way, if we do the cross products, we would have 44 times 11 plus c equals 77 times 11 minus c. So if we distribute, we should get 484 plus 44c equals 77 times 11. I'm going to get 847 minus 77c. So I'm going to add the 77c to 44c, and I'm going to subtract the 484 from the 847. And that goes to 0, and that goes to 0. So I'm left with 121c is equal to 363. If I divide by 121, I'm going to get c to equal 3. What does that mean? That's the current. So we could check this, and 44 divided by 11 minus 3 would be 8, and 77 divided by 11 plus 3 would be 14. And if we check that, we get 5.5 equals 5.5, and all that tells you is what the time would be. Next problem, we got an airplane maintaining a constant airspeed takes as long to go 490 miles with the wind as it does to go 350 miles against the wind. The wind is blowing at a 30 mile an hour. We're trying to find the speed of the plane, so we're solving for R. So I've got my distance, my rate, my time, and I'm going to have with the wind and against the wind. Now, I'm going 490 miles with the wind, and I know that the wind is blowing at 30 miles an hour. So my rate is R plus 30, and I know it's going to take the same amount of time. It takes as long as if I go 350 miles against the wind. So what I have with the wind is I have 490 divided by R plus 30, and that's going to equal time. Well, this time would be 350 divided by R minus 30. So again, if you're looking for LCMs, it would be R plus 30 and R minus 30. So we've got, we know R cannot be negative 30 or 30. So I'm just going to do some cross products here, and I'm going to get 490 times R minus 30 is equal to 350 times R plus 30. So you just want to distribute to simplify. I'm going to get 490R minus 14,700 is equal to 350R plus 10,500. So I'm going to add the 14,700 over here. And I'm going to subtract the 350R here. So that goes to 0, and that goes to 0. So I'm going to get 25,200, and 490 minus 350. So I'm going to get 140R. When I divide by 140, I'm going to get R is 180. So all that means is that's the speed of the plane. So if I'm going with the wind, I've got 490 divided by 180 plus 30, which would be 210. And then if I'm going against the wind, I'm going 350 miles an hour, and that's 180 minus 30, or that would be 150. So you look at the results here. So 490 divided by 210 is 2 3/10 repeating, and 350 divided by 150 is 2 3/10 repeating. So remember, this 3/10 repeating is the same as a third. So a third of an hour would be 20 minutes. So it takes about 2 hours and 20 minutes for the flight to go 490 miles with the wind of 30 miles an hour. But we were looking for the rate, and so the rate of the plane was 180. All right, we have a 550-mile trip, and it's a 5-hour plane trip, and it flies at 2 speeds. Okay, so we'll have our distance, we'll have our rate, we'll have our time. So we'll have the first part of the trip and the second part of the trip. So, but what we know is there's a total here. It's a total of 555 miles. And we also know it was a total of 5 hours. So if the first part of the trip took T time, T hours, then the second part of the trip was 5 minus T hours. So if we knew that the first part of the trip was 2, 5 minus 2 would give us 3. So we know 2 and 3 would give us 5. Well, the rate on the first part of the trip as we see, first part of the trip, 105 miles an hour, and the remainder part of the trip was at 115. So what we know about the first part of the trip is that we covered amount of distance. Second part of the trip would be 555 minus the distance. Well, so how do we go about solving this? Well, we've got two different variables. We've got d and t. So the first part of the trip is distance equals 105 times t. So what we're going to do is we're going to take 105t and we're just going to substitute it here. So I'm going to get 555 minus 105t. Now what does that equal? Well, that equals 115 times 5 minus t. So this will allow us to solve for t, which we'll substitute here, which would give us a distance for the first part of the trip. So 115 times 5 and 115 times t. So I'm going to get 575 minus 115t, 555 minus 105t. So I'm going to add 115t, and I'm going to subtract 555. So this goes to 0, this goes to 0, and so we're left with right here, a negative minus 105t plus 115t is 10t, and this will be 20. So t is equal to 2. So that's our time here, time here. So if t is 2, and let's look at the first part of the trip. That would be distance equals 105 times 2. So distance would be 210. So what we're going to look at is just taking the 210 and substituting it right here. So 555 minus 210 better equal 115 times 5 minus 2. So 555 minus 210 is 345, and 115 times 3 is also 345. So that shows us what we were solving for was how long did the plane fly at each speed? Well, it flew for 2 hours here and 3 hours here. So it flew 2 hours first trip and 5 minus 2 or 3 hours for the second trip. All right, so we got a lazy river and has a current with an unknown speed. A motorboat travels at a speed of 15 miles an hour, and it can travel 72 miles downriver with the current. In the same amount of time, it travels 48 miles against the current. So we're finding the speed of the current. We got our distance, we got our rate, we got our time, and what we have again is upriver, downriver. So upriver is against the current, and downriver is with the current. So we know that the speed is 15 miles an hour. If I'm going against the current, then I'm going slower, so it's going to be 15 minus c, and if I'm going down or with the current, it's going to be 15 plus c. Now this is 72 miles down the river with the current. So this would be 72, and this would be 48 going against. And we know that it's going to be the same amount of time, so we can set t as our time. So distance equals rate times time. So if I want to solve for time, I've got to take distance divided by rate. So I've got to take 48 divided by 15 minus the current is equal to 72 divided by 15 plus the current. Again, if you use LCMs, it would be 15 minus C and 15 plus C. Or you can cross products here, and so that'll give you 48 times 15 plus C is equal to 72 times 15 minus C. So this will be 720 plus 48C is equal to 1,080, which is 72 times 15 minus 72C. So I'm going to add the 72C and subtract the 720. That goes to 0, that goes to 0. So I'm left with 360 and 120C. So 360 divided by 120, I get C as 3. So that means that the what's the rate going upriver would be 15 minus 3, or 12. So upriver would be 48 divided by 15 minus 3, or 12. And then downriver was 72 miles, so that'd be 15 plus 3, or 18. And if you divide both of these, you're going to get 4 on each of them, which means it took 4 hours. What's the speed of the current, though? That's what we were looking for, was 3 miles per hour. Example 10, car and a bus set out at 2 p.m. from the same point, heading in the same direction. The average speed of the car is 30 miles an hour slower than twice the speed of the bus. In 2 hours, where they're both traveling, in 2 hours, the car is 20 miles ahead of the bus. We want to find the rate of the car. So we have a car and a bus. So we got our distance, we got our rate, we got our time. And we'll say here's the car and here's the bus. So the average speed of the car is 30 miles an hour slower than twice the speed of the bus. So R is going to represent the speed of the bus. The car is 30 miles an hour slower than twice the speed of the car, and they both were traveling for 2 hours. And after 2 hours, the car is 20 miles ahead of the bus. So we know that distance is equal to rate times time. But we know the bus distance is equal to 2R. So I'm going to take distance equals 2R and substitute it right here. So that's going to give me 2R plus 20 equals, let's distribute, and we're going to get 4R minus 60. So I'm going to subtract 2R and add 60. That goes to 0, that goes to 0. I get 80 equals 2R. So this is 40. So what does that mean? Well, that means 40 is the speed of the bus. So the bus is distance equals 40 times 2. So the bus distance is 80. Well, now that I know that, I can substitute here, and 80 plus 20 is 100. And I know the rate is 40. So 2 times 40 minus 30, all of that times 2. Well, that's 80. 2 times 40 is 80. 80 minus 30 is 50. And 50 times 2 is 100. So it just shows that the speed of the bus was 40. So that means the speed of the car had to be 40 times 2, which is 80. 80 minus 30 is 50. So the car's rate is 50 miles per hour. Last one, we've got two cyclists starting at the same time from opposite ends of a course that's 45 miles long. We got one cyclist and we got a second cyclist. One cyclist is riding at this rate, second cyclist is riding at this rate. We want to know how long until they meet. So we're looking for time. Distance, rate, time. So the first cyclist, second cyclist, and we know a total. We know a total of this course is going to be 45 miles. So how far did they go? This first cyclist is riding at 14 miles an hour. Some time. So the first cyclist, his distance equals 14t. The second cyclist is riding at 16 miles an hour. So they're at 16t. So what we want to know is that one's going this direction, and one's going this direction, and at some point they're going to meet up. Well, that entire distance of this race is 45 miles. So if we take 45 miles and we add the distance and rate, or the rate and time of one cyclist and the rate and time of another cyclist, we're going to get 30t is equal to 45. And if we divide by 30, we're going to get 1.5 as the time. What does that mean? Well, that just means that the distance for cyclist 1 would be 14 times 1.5. The distance for cyclist 2 would be 16 times 1.5. And the distance for cyclist 1 would be 14 times 1.5. And this cyclist covered 21 miles. And the cyclist 2 would have covered 24 miles. Well, that sum would give you a sum of 45.